Hello, my name is Tawachi Nyasuru. I'm an MSc student at University of Leeds. I would like to demonstrate my project entitled Smart Laboratory. It is about Internet of Things application for smart buildings. The project testbed is an aerobiology test chamber where experiments are carried out under preset thresholds of temperature and humidity. This is the setup of the implementation. We have a sensor and actuator node that is built around a chipKit WiFire microcontroller board. It's located in the test chamber. It is connected via Wi-Fi to FlowCloud. FlowCloud is a cloud computing infrastructure that is owned by a global technology company called Imagination Technologies. The data center is located close to London. It provides a platform for development and deployment of Internet of Things cloud-based applications. It is secure. It is application independent. We also have a mobile app called Make It Flow, which is also connected to FlowCloud via Wi-Fi. Make It Flow is an open source application. It's available for download from Imagination website. It provides the basic functionality for communication with FlowCloud, and I added the functionality of my project onto it to make it work for my project. This is our SmartLab node. It comprises a chipKit WiFire microcontroller board. This is the one down here. On top, I've put a shield adapter just to extend the ports. This is our phase sensor. It's a temperature sensor. It's connected to port A0 of the microcontroller. The second sensor is a humidity sensor. It's connected to port A1 of the microcontroller. And here we have a fan actuator. It's a digital relay. It's connected to a digital port of the microcontroller. And here we have a battery for the microcontroller. This SmartLab node is programmed to do the following tasks continuously every 30 seconds. Firstly, it will capture the sensor reading, that's the temperature and humidity, and immediately it will save it in the device data store on FlowCloud. Secondly, it will compare the current readings with the set thresholds. If the temperature is exceeded, it will automatically close the contactor for the fan to switch it on. This is the output from the console. As you can see, this is the temperature reading. This is the humidity reading. Then it will save these readings on this URL, which is the URL for the device data store. And if saving is successful, we'll get a message here, as we have got here, data item saved successfully. And it also says that the temperature setting is exceeded and the humidity setting is exceeded. By default, the temperature and humidity settings are 0 degrees Celsius and 0% for relative humidity. That is why it is saying that the humidity setting is exceeded as well as the temperature setting is exceeded. I'll now demonstrate how to interact with the sensor node using the Make It Flow app on my Android phone. I'll start the Make It Flow app. I'll log in. Once I log in, it will take me to the connected devices page. Once it establishes connection with the node, it will turn green and I can interact with it. The first command that I will show is the set temp setting, which is used for setting the threshold for temperature. So I'll enter the temperature threshold. It's in XML format. I'll set the temperature to 25 degrees, which is above the current reading of around 22 degrees Celsius. So since the temperature threshold is above the temperature reading, it should no longer sense that the temperature setting is exceeded, and at the next sampling it should turn the fan off. So let's see. Yeah, the fan is now off because the temperature is no longer exceeded. A user can also retrieve the temperature setting at any time, the current temperature setting that is, by using the command get temp setting. For this command, we don't need any command parameters since we are just inquiring about the current temperature setting. I hit send and we get our temperature setting as 25 degrees Celsius, which is the same that we had entered. These two commands are similar to the ones for humidity, the set humidity setting and get humidity setting commands. The third command that I will demonstrate is called the get measurements command. This is a command for retrieving the current temperature and humidity readings from the node. So when I hit send, in the output we can see the temperature reading as 23 degrees Celsius and the humidity reading as 30%. Lastly, a user can manually delete all the data store items from FlowCloud using the command clear data store. So if I hit send, I'll get a message that it's deleting sensor measurements from FlowCloud. The user can also override automatic operation of the fan by manually switching the fan on or off using the mobile app. For this one, we are going to have a user joining us via phone call from Lilongwe in Malawi to demonstrate. His name is Kondwani. He has installed on his Android phone the version of Make It Flow app that I customized for this SmartLab project. To put things into perspective, here's a map of Europe and Africa. The sensor node is located here in Leeds. It's with us here in Leeds. The FlowCloud infrastructure is in London, UK. That's 272 kilometers from Leeds. Kondwani is in Lilongwe, Malawi, which is 7,948 kilometers from London.
Hello.
Hello, Kondwani.
Hi, Kawachi.
Yeah, we are set, yeah?
Yeah, I'm set.
Okay. Now, Kondwani, send the command set fan on and inform us when you are clicking on send so we can appreciate how long it takes for the fan here to respond.
I've selected set fan on. And I'll hit send.
Yes, the fan is now on here. So now, can you switch it off for us?
I've now selected set fan off. And I'll hit send.
Alright, the fan is already off here. Thank you so much, Kondwani.
Alright, thank you.
Bye.
Bye.
This application was successfully tested in Leeds, in London, in a moving train between Leeds and London, and in Lilongwe in Malawi. The average response time in all these test scenarios was under 2 seconds. Thank you for your attention.